Welcome back to Math 095, Metric Conversion and Dosages. We're going to continue talking about operations with fractions and decimals. Let's do a little more work with decimals. Let's talk about adding decimals. Now, you have a calculator. You can punch that right into your calculator as it's written. However, sometimes you may be in a hurry, and maybe your calculator batteries are dead, or maybe you're in the field in an emergency situation. Everything that we're learning in this course, you should train yourself to do on a calculator, by hand, and in your head as much as possible, because each of those techniques allows you to check the others. Because you could punch in something wrong in the calculator, and then you could check it by hand. Or you could check it in your head and say, whoa, that is way off, that can't be the answer, let me redo that. It's a safety check, being able to do it by hand, on a calculator, and in your head. Punching this addition into your calculator as it's written is no problem. However, if you're going to do this by hand, I recommend you go ahead and rewrite it vertically, lining up the ones place, your decimal points, the tenths place in each of these. Oh, and then this one, it even goes out to the hundredths place. But they are all lined up vertically before you add. And for those numbers that do not have digits out to the hundredths place, you can add zeros as placeholders if you want to. As always, we start in the rightmost column. 0 plus 0 equals 2. 0 plus 8 plus 3 equals 11. There's my decimal point, but I need to carry the 1 from the 11. 1 plus 5 is 6 plus 7 is 13. 13 and 12 hundredths. The first example was a reminder of how to do addition with decimal numbers. Here's a reminder for subtraction. Once again, you can punch it into your calculator just as it is. I think it's easier to do this one if we write it vertically when we're working by hand. Yeah, I didn't give you an easy one for this example because 6 cannot be subtracted from 3 very easily. 5 cannot be subtracted from 0 very easily. So starting in the hundredths column, 6 cannot be subtracted from 3 unless we borrow some value from places to the left. Well, there's nothing in the tenths column to borrow there. 0, there's nothing there. Okay, so we're going to have to borrow from the 4. Let's take 1 from the 4. That will give us 10 tenths, okay, but we still don't have what we need in the hundredths column. So we're going to have to borrow a tenth here, leaving this as 9 tenths. And now we have 13 hundredths minus 6 hundredths will give us 7 hundredths. Okay, good. Now looking at the tenths column, we have 9 tenths minus 5 tenths equals 4 tenths, and there's the decimal point. And 3 minus 0 is 3. So 3 and 47 hundredths is the answer to that problem. New screen. All right, let's work on a multiplication problem, one that could easily go into your calculator for solution. But let's work on it by hand. I'm going to scoot it over so I have a little bit more room here. And I'm going to rewrite this vertically. However, when you're rewriting multiplication like this vertically, you don't actually have to keep the decimal point lined up. In fact, because for a little bit here, we're going to forget about those decimal points. We're not going to forget about them completely, so I'm going to actually rewrite them in here in a little bit lighter color, because we will be using them in our final answer. And we're going to multiply this. I'm going to do this. I'm going to do 5 times 2 is 10. I'm going to write the 0 here and carry the 1. Now, I'm not going to go into the Common Core math explanation of why this is true. I'm just going to give you the nuts and bolts way to do this, okay? So, 5 times 3 is 15, plus 1 is 16. I will write the 6 and carry the 1. 5 times 6 is 30, plus 1 is 31. Write the 1, carry the 3. 5 times 1 is 5, plus 3 is 8. Now, I was multiplying by 5, which is in the hundredths place. Now I'm going to go and multiply by 0. That's not in the hundredths place anymore. that 0 is in the tenths place, which is worth 10 more than the 5 was, or it's worth 10 more than the hundredths place. So I'm going to indicate that by putting a 0 right here. This 0 starts in a place that is worth 10 of the previous place, the hundredths. Okay, so now I'm going to multiply. 0 times 2 is 0. Wait a minute. 0 times 3 is 0. It's going to be zeros all the way across through there, so it's all zeros. Why even write that line? Okay? But my first line is the hundredths. My next line is the ones. So that's 100 times what I worked with before. So it's not 10 times more, it's 100 times more. So I put 2 zeros. Wow, hand's really shaky today. Okay, so 9 times 2 is 18. Now, I have a problem here. I forgot to erase my carries, so I'm either going to have to erase them or just, mark them out, get them out of the way. Okay, 9 times 2 is 18, so I'm going to carry 1. 9 times 3 is 27, plus 1 is 28. Carry 2. 9 times 6 is 54, plus 2 is 56. So 6 here, new column, carry 5. 56 I said, right? And 9 times 1 is 9, plus 5 is 14. Okay, and add those all up. 0 plus 0 is 0. 6 plus 0 is 6. 1 plus 8 is 9. 8 plus 8 is 16. Up, carry 1. 6 plus 1 is 7. Then I have a 4, and I have a 1. Okay, but now we have to remember these decimals, because I wasn't just multiplying by 5 here. I was multiplying by hundredths. And I wasn't just multiplying whatever was in the bottom number by 2. I was multiplying by 2/10. So basically the way we do this is we count the number of places to the right of our decimal place in each of these numbers. So here there's 1. Here there are 2 places. So I start from the right and I count over 3 places. 1, 2, 3. And that is where my decimal point goes. So 163 and 2/10 times 9 and 5/100 equals 1,476 and 96/100. Or if you are being as precise as possible, 1,476 and 960 thousandths. Okay, let's do some division. Example 4. We've already done some division, so I'm not going to start at the very beginning. Let's do something challenging. Let's do, 15 divided by 0.06. Let's see what that turns out to be. 15 divided by 0.06. All right, with multiplication, I didn't have to be so careful lining things up, but boy, with division, you do have to be. Now there's a decimal point in my divisor. Where's the decimal point in my dividend? It's right there, to the right of the 5. They're not in the same place. I have hundredths in my divisor. If I think about it as the fraction, I don't like that decimal in the bottom. Okay, that bothers me. I much prefer a whole number numerator and a whole number denominator. So let's not change the value. Let's multiply by 1. Well, if I multiply by just 1, it doesn't do anything for me, does it? Well, it does if I multiply by 1 in the form of 100 over 100, because look what happens. I get 15 times 100, that's 15 with 2 zeros, and I get 0.06, but I'm moving the decimal place 2 places to the right, which is actually what I did in the numerator too. But that gives me 6 in the denominator. So I now have 1500 divided by 6. Now I really didn't have to go down here below my original work to do that. I could have just said, I'm going to multiply 6/100 by 100 and 15 by 100. So I'm going to Move the decimal place 2 places there also. And now my numbers have become 6 and 1500, or 1500. So from now on, I'm not going to justify what I'm doing here, moving these decimal points when we divide, by referring to the fractional forms. But now you can look back at this and understand why it works. Now that I've moved my decimal point to its final resting place, I'm going to put a decimal place above the bar, exactly above it. When you're dividing, keep everything in neat columns. All right, 6 goes into 1. Doesn't go in there. Nope. All right, 6 goes into 15 2 times. Let me make that a little bit bigger there. 2 times. 2 times 6 is 12. Now I'm going to subtract 3, 0, because I have to bring down a 0. 6 goes into 30 5 times. That gives me nothing. 0. And if I bring down a 0, I get 0. Well, 6 doesn't, it goes in there 0 times. There I go. I don't have anything out here, so I don't need to continue bringing down zeros forever. Okay, just not necessary. So our answer to our original problem that was written as a fraction bar indicates we do 15 divided by 6/100, and that gives us 250, as shown by the long division to the right, or by your calculator if you punch in 15 divided by 0.06, because your calculator doesn't need that initial 0. You should get 250. Now we just looked at this fraction, and we determined that this comparatively large numerator of 15, when it was divided by this tiny denominator of 0.06, gave us an even larger number. It was equivalent to 250. But what about a number like, I don't know, 2400 over, let's see, 0.203? Okay, which one's bigger, the numerator or the denominator? Well, they're lined up pretty well right there, but let me just take out the division bar. Because when you are comparing fractions, it really helps to write them decimals, to write them one over the other and compare each column. Well, in the ones column, they're exactly the same. In the tenths column, they're exactly the same. In the hundredths column, this number's bigger. It has 4 hundredths. And in the thousandths column, if we put a 0 there, the second number is bigger. It has 3 in the thousandths column. But which is bigger, 40 hundredths or 3 thousandths? Remember that as we're going this way, each place has comparatively less value. So the answer is the one with the larger number first. Reading from left to right, when you find a column where the digits differ, the number with the larger digit, the larger value in that column, is the larger number. 0.24 is greater than 0.203. And you could see that if you rounded each of those numbers to the hundredths place. Clearly, 24 hundredths is bigger than 20 hundredths. Okay, so that's another way to think about it. But in this case, the number on top is larger, and you're dividing by a smaller number. Why is that important? Let's try this larger number and this smaller number. And if you do that division, you're going to get a repeating decimal. I'm going to stop repeating at, okay, it keeps going. Running into my other things, so, I don't have room. I'm going to round here. And I'm going to follow the standard rules of rounding. That's a 6, so I'm going to add 1. Okay, let's take just a moment and compare 7 over 6 to 6 over 6. The numerator and the denominator are the same. That's equal to 1. Anytime the numerator is bigger than the denominator, then you have something greater than 1. If the numerator is smaller than the denominator, what is 5 divided by 6? That's 0.83 repeating. I'm just going to stop at the hundredths this time. It's 3 all the way out to infinity. So 0.83 is less than 1. Whenever you have a numerator that is less than the denominator, you have some value that is less than 1. It could be substantially less than 1, like 17 over 10,000. So I write 17. So I'm going to move my decimal 4 places to the left. I'm going to fill in those swoops, put in the decimal point, and because I want everybody to know there is a decimal point there, I'm going to put that 0 to the left of the decimal. So 17 10,000ths, there it is. Wow, there is so much stuff to cover. Basically, I'm trying to take you from learning to count to working with fractions and decimals in pretty complicated forms. So this video is getting a little bit too long. We're going to have 3 videos trying to get through all of the concepts involved in just basic operations with decimals and fractions. So look for video C.